In today's world, human healthcare is of vital importance. We need cheap and innovative solution to address the problems of vast number of patients in the Indian population. For this purpose, we have developed a device which can measure fluorescence from liquid samples called PRATIDIPT. This device could be useful for many bio-analytical laboratories, for medical diagnostics and so on. In that sense, we present to you our innovation, which is a bio-analytical device that can measure the fluorescence from a liquid sample. So, we have developed a working prototype of a low-cost portable fluorescence measuring device which we call as PRATIDIPT. So, the problem being solved is as follows. See, most of the labs require cheap indigenously made fluorometer to measure fluorescence from target molecules in a liquid medium. This is of everyday need for many medical laboratories, for analytical labs and so on. The commercially available fluorometers are very expensive because they are imported. They can cost more than 20 lakh rupees. They are bulky and heavy because they comprise of high voltage power supply, xenon lamps, lamp housing units to cool the surroundings, and also you need a monochromator which requires moving parts. So, all this make the instrument bulky and also they increase the cost. So, the main problem today is that we don't have indigenously made fluorometers in India. There is no company which makes it in India. So, this has to be addressed. So, for this reason, many of the teaching labs and laboratories which do analytical work, the R&D labs in industry, they cannot afford buying a fluorometer. So, our product PRATIDIPT could address this problem and could be a solution.
With the aim of developing an affordable and portable fluorometer, we have designed the prototype of fluorometer PRATIDIPT. Let us look at the construction and features of PRATIDIPT. The fluorometer consists of the following main parts: LED light source with adjustable intensity, sample chamber, photomultiplier tube as the detector, and an electronic circuit board with LCD display. The instrument comes with a DC supply unit and can work on battery or AC mains. A single printed circuit board holds all electronic components like microcontroller, switches and LCD display. LED of required wavelength is chosen. The source intensity can be adjusted. At the detector, optical filter is used to block excitation light and pass fluorescence wavelength. To make the device portable and affordable, the following features are incorporated. LED is used as an excitation light source instead of xenon lamp. Optical filters are used to get rid of monochromator that requires delicate optical assembly and moving parts. Photomultiplier tube is employed as detector to enable sensitivity to nanomolar concentrations of sample. The instrument has built-in display to indicate the result. It consumes low power and can work on a battery. The estimated cost of the fluorometer is about 20,000 rupees.
So, now let me describe the working of a prototype which we have developed. So, as you can see in the video, the power is turned on, followed by switching on the PRATIDIPT device, In the first step, we want to see the response of the instrument when there is no fluorescent molecule in our sample. For this purpose, we prepare a blank sample and record the background signal as it is shown. You can see that the background signal is very low, close to 0. So that means the instrument is fairly faithful in reporting the presence of your fluorescent molecule. In the next step, we measure the fluorescence from a dilute sample. Our sample here is fluorescein in 0.1 normal NaOH. So as you can see, we are observing a moderate value in the measured fluorescence around 128. So this means that we are able to detect the fluorescence coming from the fluorescein molecules in the sample. Next, we examine the response of our device for a concentrated sample of the same fluorescein. As you can see in this measurement, the value for the concentrated sample is quite high, close to 1000. So our device is able to measure the fluorescence coming from the concentrated sample and also from the dilute sample as it is displayed. Now let us look at the fluorescence intensity plotted against the concentration. As you can see here, there are two plots, the absorption intensity plot on the left and the fluorescence intensity plot on the right. We observe that fluorescence intensity plot faithfully displays a pattern which is very similar to what is seen in the absorption plot. This indicates that our device is sensitive enough to pick tiny changes in sample concentration. So in essence, we can demonstrate that our device can track the concentration of fluorescein from nanomolar to micromolar concentrations.
In our ancient language Sanskrit, the fluorescence means PRATIDIPT. So we have named our device as PRATIDIPT. Currently, the working prototype of PRATIDIPT is fully functional, it is in operation and patented too. The addressable market for PRATIDIPT would be pathology laboratories to carry out various tests which involve fluorescence measurement, bio-analytical laboratories, research institutions, teaching purpose laboratories in academic institutions, and also the industries where biochemical and analytical measurements based on fluorescence are being carried out. What would be the potential impact of our innovation? In various pathology laboratory tests, the fluorescence is being measured, like proteinuria quantification test in kidney malfunctioning. Being a cost-effective solution, as the initial cost of the instrument itself and its operating cost is substantially low, it reduces the cost of the laboratory tests. So the economic benefit will straight away pass to the patients. The PRATIDIPT design has been improved with the safety feature. Normally, the fluorescence measuring devices possess the bulky and high voltage sources. But in this design of PRATIDIPT, we have removed all such high voltage and hazardous sources, putting forward the motto of operator safety and instrument safety. The design of PRATIDIPT is made in such a way that it has removed all the rotating and moving parts inside. So the device is absolutely a zero maintenance device, as there will not be any wear and tear action. So academic institutions will be absolutely benefited with this feature. No rigorous training is required to set up this instrument for measurement of fluorescence, so students can easily perform their fluorescence measurement experiments using this PRATIDIPT. As the device sensitivity ranges from micromolar to nanomolar, the research institutes and such research projects where cost of a project include the cost of the analytical instrument employed. So there our device will be the appropriate and value for money selection.